Off here. Yes.
Which number round?
Great.
2.2.
We're gonna have a class.
Give me just like a quick
2.2. Yes. So find this using the power rule, leveling up. So we did polynomials. Not so bad. Recap of polynomials. You take the exponent, you put it out in front. So then you have two coefficients. You multiply them out, and then you subtract one from the exponent. Check. That's power rule. So anytime you have something that could be rewritten as a negative or fractional exponent, you must do so. Has everybody found this page? Not everybody's on it.
Sorry.
It's okay. I just don't want to leave you behind. No person left behind. Okay, so go ahead, rewrite this with a negative exponent. Oh, I already gave it away. It does have a negative exponent. It could have been fractional. I wanted you to figure it out. It has a negative exponent. Rewrite it. Yeah, maybe we should do it together. So here's how I think about it. So let's do y equals. So the 5's on top, the 2's on the bottom. And I'm going to rewrite this x to the third as x to the negative 3. The more we do these, the better you'll get. But I want you to actually keep y equals, okay? Keep y equals. Because you know how like normally you can leave off the y equals because everything's equal to y? We've never had like different versions of the same function, but we're about to get y primes. So we need to keep track of the y's versus the y primes. Ready to differentiate? All right, I'll set you up. The negative 3 comes out in front, multiply, and then you're going to subtract 1 from the exponent. Let's try that out.
Subtract 1 as in negative 4 or negative 2?
So literally do negative 3 minus 1.
So negative 4.
Correct.
Why wouldn't it be negative 2?
This is the, you know, because it's subtract 1.
I know.
How's this?
Yeah.
So, misconception alert, 3 minus 1 is 2. Saying negative 2 is a super common mistake, right? We're not going to do that. Can you go ahead and rewrite it so it's still y prime equals, right? So simplify it. So like take away the negative exponent. How can you rewrite x to the negative 4? How can you where can you put it so it doesn't have a negative? This is backwards. It has a negative exponent, so you're going to write it with a positive on the bottom. So it's negative. I just put the negative out in front. You could totally leave it up top, but I just put it out in front. 15 over 2x to the 4th. So this overall thing of you're given your function, rewrite, differentiate, and simplify. I could call simplify like rewriting again. You know, I could say rewrite. But this, you're going to do a lot. This is like a common thing. We're going to do this like throughout the year with lots of different rules. You're going to have to rewrite stuff a lot. Okay, so try this one. I'm going to rewrite it. There's actually 2 rewritings, okay? I'm going to rewrite it as 5 over, what's the bottom?
2. I mean, x.
8x cubed.
8x squared. No.
That's a cubed. Oh, you're thinking, oh, you're deriving already.
Oh.
So, yeah, so this is why the boxes need to say, like, right, so now we're just rewriting, so you're not subtracting or multiplying. So can you rewrite it again now with a negative exponent now? Or fractional, but I just told you it's a negative exponent. Okay? So now go ahead and differentiate. So this is where you do the product and subtract 1.
For differentiating.
We are differentiating it. Is that it? You did. Because both terms get equal. So the negative 3 comes out in front. Subtract 1 to the negative 4. Rewrite that a final time, please. Please. It's a llama. No, that's. Oh yeah, that's an alpaca. Yeah. Hello, welcome. They're different animals. Alpacas are much smaller. If you actually were to see them in real life, llamas are very large, and alpacas are not that large. Yeah. Can you come sit? Can you sit here, gentlemen? Thank you. All right, are we? Did we do this? Should we put up the answer? Okay, cool. So super similar. Alrighty, new one. Alrighty, let's do this. So we have g of x. Its name is g of x. We're doing 2.2. So just find this side. So rewrite. How do you rewrite cube root of x? So x to the 1/3, right? Now try differentiating.
1 cubed third.
See, even then, it's like, you can't be so like you can, but.
Like, because it's slayable, but no, she won't get it.
All right, should we differentiate together?
Yes. Wait, it'll be like.
So 1/3. So you have g prime of x. Did you change it to g prime? Good, good, good. So 1/3 comes out in front, times by the coefficient that's there, it's just 1. So it's just 1/3 out in front, right? X to the negative 2/3. Okay, you just take 1/3 and subtract 1, that's negative 2/3. Okay, now try simplifying that for one final time. So get rid of the fractional exponent, get rid of the negative exponent. So I want you to rewrite it with no exponents. Okay, that's happy there. And now have you rewrite it.
Is it negative? Oh, it's negative. It's over 1, right?
Okay, let's go one by one with the terms, okay? G prime of x. So what's on top? There's a 1 on top.
Yeah.
There's 3 on the bottom. Okay, so check, check. X to the negative 2/3, is that on the top or on the bottom? Bottom. 2/3 becomes cube root of x squared. Okay, so if you take every tiny little thing and say, does this go on the top or bottom? Does this go on the top or bottom? Does this go on the top or the bottom? That's a good strategy. Yeah, the 3's on the outside. Yeah. Let me see, do you have more fractional exponents? Yeah. I want to change this one to another fractional exponent. Let's change this to, 1 over, let's take the derivative of 1 over root x. Can you change it to 1 over root x? No, let's make it 5 over root x.
Mine even got no shells.
I know, sorry. 5 over root x. 5 over root x. It takes you long to try.
No, it's not even that. So like it's so loud because I have to shake it and like I don't know.
I think we can handle it.
Oh, it's just here.
You can rewrite it.
Oh, you're right out. You just like cross these out.
So you have 5x to the negative half for starters. Negative half. Yeah. Yeah, negative 5 over 2. X to the
Negative 1. Negative 2.
So what's yes, good job. So what's negative a half minus 1? Negative 3 halves. Okay. So now simplify it. Just ask yourself, just put a negative out in front, make your fraction, and say, is this on the top or the bottom? Upstairs, downstairs, numerator or denominator? So I know that you can simplify square root of x cubed as x root x, but you'll never have to do that. This is good. Well, not never, almost never, but like, this is good.
I saw it too, like, oh, I gotta put it right here.
But questions on this?
What?
All right, so what we're doing, the procedure we're doing is rewrite, differentiate, simplify. Rewrite, differentiate, simplify. Rewrite, differentiate, simplify. Okay, so let's go. Alrighty, keep going. We got more. So if I put an x here, like, see this? That means that there's simple enough problems that you don't need to rewrite and differentiate. You just like write the answer. Does that make sense? So for this one, you just write the answer. It's like one step. That's good. Okay, you took the derivative. That's.
You know I said it all.
You did that in your head. That's right. That's the correct one. Actually, it's close though. So you need to rewrite it first. So see this should be in the rewriting box.
Let's go. Make a fraction.
If you're good with f of x, you can move on to f of t. You can just keep on keeping on.
Yep, that's what I got.
Okay, minutes up. Yes, done. Wrong choice. Forgot to put that prime. Whoops. Yeah.
There's a lot of moving parts.
Two.
Like seriously.
And then.
I know you know how to multiply and subtract one, but
You don't need to do for the square root.
Yeah, x and then -1. Yeah. That looks correct.
You did.
okay, so this is the answer to the first one. Now try the second one.
It'd be 1 over where
So you understand like both ways.
Yes.
It like turned to a G.
Yeah, like the, so it'd be,
Okay, how do I actually bring it back up?
so you gotta take the 2 and multiply it out front. So you have to do 4 times 2, so it'd be 8. It's still over 5, so you just like over 5. So 8 t.
negative.
You're just standing over me. It's gonna be stage.
Well, it doesn't have it
Fill in the denominator.
I like that.
because like what's 2 minus 1?
I like that. I walk in, I'm like,
So
oh,
positive
here's
1
more
is just
students,
1
I'm
over
just here
8.
scared of
And like, slow it down.
Can you slow down? I'm on differentiate. Okay.
Yeah, like on, no, the t's on
I was
top.
just doing out the exponents.
Yeah, because this isn't a negative exponent, there's nothing,
I don't move that
negative
fast.
exponent.
So what's the coefficient there?
Yes.
Yep.
Negative
Does that make
2 over
Yes.
6.
Yep, right.
Negative 1/3.
And then next to it, give me an x to the, what's the power? You know, there's a beast.
I mean, there's a gap.
There's a beast cover, that's what I'd like to
The,
say.
What happened?
reverse.
Oh, that's very good also. What did I do?
Math. So you know how it's minus 1?
Yeah.
So it's negative 2/3
Oh,
minus 1.
-1.
Ooh!
So you added 1.
What's the
It's
coefficient
5
here?
thirds, right? Negative
Negative
5
5/3.
Yeah.
Isn't that two?
That's 1 divided by 2 gives you 2.
Oh.
Yeah. No, I get all the flashing lights, the cameras flying around all day. You forget that 1 divided by 2 isn't 2. I get it.
Cube root.
Oh yeah, it's super close. Wait, no, it's not.
The 5 on the
So you need to.
Is that correct? I don't want to.
I don't know.
So what's a
Yeah,
half minus 2?
okay, yeah. This is
Yeah.
correct.
Just x. And then what's a half minus 1?
That's sick. You just lost the negative. Should be a negative in front.
You,
I mean,
that's
it
what
was
you
a negative
do.
1/3
Oh.
here, and
What's a
then all
half-
of a
what
sudden
is a
you're
half
not a
minus
negative
one?
anymore.
No.
So you put the negative 1 and the negative 1 on the top is fine. You can put it in front of the whole thing, put it with 3, whatever.
Wait, why did I
You
subtract?
gotta-
Because you always take the exponent and subtract.
Is it just like done? What is there left to do? Wait,
Yeah, where did I get that?
and then that's like.
Yeah, oh, yeah.
And then
2 over 6, 1/3.
Negative 3 over 2.
It just like. Yeah.
Yeah.
Okay.
Oh, yeah.
My copy of you're doing correct things or like totally terrible things. It's good for me to know.
Much more.
I mean, technically it was correct.
Just make a fraction.
Yeah, jack you up. You're right.
What's
Right
the
when he walked in
That
here,
is
we
the
started
fuck, that's
talking
always
about
the
white
negative.
out.
This is x and negative x. There's x has a negative x. One, just one. I don't see a negative.
This is energy, like, we're like, oh, we should be doing like, but no, we don't.
Whole X is 0.
That's one, right?
Okay.
But just like, right, this is like,
So if we do it in
what's the
2 steps,
coefficient here?
let's get rid of the negatives.
negative 3 over 2.
So that's the
So it's
same.
like this, it's like anything
Yeah,
that's
it's
constant.
so
By
fun.
putting it.
It's just 2.
Oh, yeah.
It's like 6x, it's just 6. It's just
Yeah,
exactly, it's just
okay.
a line with the same
That
slope.
makes
and it's
sense.
like this, it's just negative 3 over 2.
Okay.
I think I'm going
Yes.
to because macro.
You're kidding me, right?
No, no.
Oh my goodness.
That's not, you don't like that?
That's why like, I actually don't hate or rewrite for that one. Because you see, you like write it more like a line when you rewrite it, you see that. But yes,
Ew,
exactly
like,
that.
one.
Yeah, and little negative 3 halves x.
Yeah. Oh wow, this is wild. This year when you see AP questions, it's like, we're taking that. As opposed to like, oh, we're skipping that slide.
All right. So a little bit of this.
Oh, you know AP question, what? Oh, why are we waiting around?
Patience.
For what?
Okay.
Yeah, the questions are really
We're
fast.
able to subtract now. We're getting better at subtracting one from things, probably.
No.
Yeah, no.
Not even.
I think it's interesting. A half in the, like a square root in the numerator ends up as a square root in the denominator. Because a half minus 1 is negative a half. It's like interesting, yeah.
I don't think we can do the fractions.
This last guy is just a line, so the slope of a line is a constant. Oh look, I did read it, yeah. If you wanted to rewrite it. Well, I mean this is like a little extra, but you could rewrite it just so that it looks more like mx, you know? But if you wanted to use the power rule, see how I do 1 times coefficient and then x to the 0, which is why it goes away. Okay. So we're ready for APQs now, huh?
No. Yeah, Rose.
All right, APQ1. All righty. So this is f prime of negative 1. So here's your first step. You're going to find f prime of x, okay? And you know how our process is rewrite, differentiate, simplify? So I didn't put in the little boxes for you this time. But you should still do that. But this time, you're on your own. They're going to rewrite it.
We're going to do all those things.
They're going to do all this. Yeah, we don't need my grids. You
Yeah.
can make your own little grids. Right. If you want, you can put a little rewrite, diff, simplify, a little bit of that.
That's cute.
You know? A little RDS. Whoa, a thumbs out. Come on.
Oh,
I know.
as what?
Next item.
Let's go.
I'll do APP for you.
That's negative 3.
Wait, isn't this the constant?
Yeah.
Caitlin, you're ahead of me. Sorry. Negative 1.
I feel like this
Wait,
could be a
negative
lot
1
simpler, but
at
I don't know.
Just 3 parts.
Yeah, but like 1 over x, like there's a lot of stuff.
Okay, I hear that.
Oh, that's not even.
Negative 1 and x.
That's good.
Okay, for the full
Am I
root,
wrong?
you get
I think I'm right.
Oh wait,
No, I have to be wrong.
I rewrote that.
No, because if the power here is 1, then like, no, I'm
this
wrong.
one.
It's 1 over x. So it's just
Oh,
squared.
squared. One and a half.
Okay, that makes
1
sense.
over 2?
Yeah, right? You just have to rewrite it again?
Oh, yeah. Wait, what?
Or do you leave
Wait,
it?
no, you're right.
He's a demonstration.
You're right. Just, what? No, you're right.
Well, let's see.
You're right.
Let's see if I'm right.
You're right.
No, I'm not right.
But you are.
Okay, so the derivative is
I'm not.
negative 3x squared, check.
Yeah.
Plus 1,
Yeah.
check. Then the plus turns into a negative,
Okay.
because the negative 1 is the coefficient, x to the negative 2. Simplify that.
See, this is where you
You still have negative 3x squared plus 1 minus.
Oh,
see, Caitlin.
wow, it's minus.
You're right. Told you.
Because, like, I wasn't wrong, but I also wasn't correct all the way.
It's the derivative of cosine. Wait. It's the derivative of cosine.
Okay.
So it's not.
Rewrite
Tangent?
Yeah, so how do you rewrite, basically, how do you rewrite x to the negative 2?
Huh? Secant?
I forgot how many times you're not wrong.
We're going to derive it, not too, in like a couple weeks.
Anytime anyone
Maybe next week we'll. You could guess that.
Oh, you haven't done it yet? They're just doing
None of us
this for
were
kicks?
even
Oh, I
correct.
take it back. I didn't say anything.
No, because we saw it.
No, we got to learn the quotient rule so we can derive the
Yeah,
derivative.
I kind of figured. I was like, why are we trying to get the derive?
Okay, you got,
Derivative of sine is cosine. Derivative of cosine is negative sine.
Victoria, you get 1 over x squared?
You just said steak. I was like, what is that?
Oh, okay.
Oh, I was crying. You're so sad.
Alright, then you're like water, I guess.
Whoa.
He goes.
So it always changes to a positive?
Yeah. you mean. Like if you put it, yeah, like a negative exponent, you always put in the denominator and make it positive.
Weird, right? I don't know how, like.
Okay, so f prime.
It popped down.
All right, guys. So f prime of -1. Did you just substitute into the thing in the s column?
Yeah.
-3.
It's like a.
-1 squared plus 1 minus 1 over
Yeah,
-1 squared.
Freaking
Still has an
waffles.
effect.
Huh?
Yes.
What if it doesn't exist? Like, would it tell you an equation? Like, would it come out to be like something over 0? If you like, if the slope of -1 did.
If you plug in and you get 0 in the denominator, the answer is does not exist.
And that's the reason you know. Like,
Yeah, so if you get like, you'd have to get a number on top, right? Not like a 0 on top. You'd have to get a number on top and a 0 on the bottom, and that would be does not exist. We will not encounter that for a long, long time.
They still do the questions. It'll like give you the absolute value one basically that was on the do now, but without a graph.
Yeah, yeah,
Yeah.
yes, correct.
Yeah.
And you have to know to, yeah.
It's like graphing strategy versus.
Versus like finding it.
Yeah.
Alrighty, we got another one. So this is nice. You say thank you. Oh my gosh, it could have written square root of x cubed, right?
I'm so grateful.
But yes, you're so grateful. Okay, so again, so like last time, you're finding the derivative at 4. So first, you're going to find the derivative at x, and then at the very end, substitute in the 4.
Choose just one page over.
And I put 3 weeks over.
I'm just that excited.
So excited for math.
That's the spirit to it.
So you don't have to rewrite this one. It's already in friendly form for you. Oh yeah, you need another black marker.
Now I know
Yes.
what to do.
That'll work.
Oh, 3 weeks. What's 3 weeks?
Yes.
Wait. Wait, it would be like this, right? Hold on. Right.
Yeah. Got that. Oh, you're so smart.
Thank you very much.
Okay, that's
I don't have these ones very often.
just be careful you got a brush. What's 3 halves minus 1? Oh, we don't get better with time. Yes.
They're gonna be like, what were they talking about?
This is.
If they even watch it.
I should probably watch it just to see how much it was.
So now that's the differentiate,
When
then
you
simplify
come
that.
see me, come give me a high five.
Okay, but.
That's Caitlin.
It's like a Bible.
They're not gonna watch
Do
it.
the same for me if you can recognize my voice.
3 over 14.
Wait, okay. What's next?
No, rewrite it.
Did you write it?
3 over 2.
Did you rewrite it?
2 radical.
What'd you get?
Wait,
Hold on.
Just make it
isn't it
Okay,
the same
yeah,
thing?
yeah,
Okay, 2.
2 times 2 is
So
4.
simplify it. So
That's not right.
You changed it to root of it.
Yep. You do. Okay. And now, so that's f prime of x. So f prime of x is 3 halves root x. So now find f prime of 4.
Wow. Go around.
Oh my gosh, what do we do?
You should have taken the big words.
I thought there was
Is it
a
three?
What?
Three?
I'm not, yeah.
That's why we're so
Good.
confused.
Alriady, C3.
There's no negative.
Hold on,
P-O?
wait. Me and Caitlin are confused. What's going on?
See, we thought there was a negative in front of us.
Okay.
Yeah.
Why do you think it was a negative?
Why? I probably just saw one in my brain.
Habit.
Why just
Yeah.
be.
Okay. All right,
Yeah.
APQ3, so definitely make that grid, the RDS, rewrite, differentiate, simplify. Okay,
This is 2. 6 over 2 equals 3. The answer is.
Wait, what was the answer to that?
3,
Yeah, it is.
yes.
That is horrible.
3x squared for the first one.
I didn't know it was gonna work or not.
Wouldn't this one be like?
You make the square roots, then you just compute.
Get that far. I rewrote it. Now you're moving too
I'm
fast.
sorry. Wait, no, it might be like over 1.
No, it's -4. Get the add one.
Yeah, but the first exponent is positive.
No, you have to rewrite it.
Thank you,
No,
Caitlin.
You don't know what I did.
No, you didn't.
Okay, let's see, rewrite it.
You really tell me that exponent's a positive 3 over, you wouldn't care.
So 1
We
over
have to
x
rewrite
This
it.
is fine.
This becomes this.
Are you thinking negative exponents or fractional or something?
Negative 3 minus
Nope,
1.
Yeah, it does. We did on the blank page.
So 1 over x.
Wait, so why
Remember
was
the
I
ones you're
wrong?
doing in the big
So
chart?
just
No,
x.
x to the negative 1.
Because that's
No.
negative 1 and then
Okay, the next one.
Not negative and 1/3. Which one is it? Negative 3 or
It's the one for the middle one.
Two,
Two,
right?
right?
I don't know.
And then
Oh,
two.
minus this should be
Put the X in the ground.
X to the one or is it X? Is X.
Right, you know,
I know. So if there's no roots, there's no fractions. So just like there would not.
That's me stuck in my neck.
Like, so see how you look through this whole problem, no roots, you're never going to have any fractional exponents right off the bat.
That's a negative.
Okay, and then for 1 over x.
Yep, how do you do that?
No, just cross out the wrong thing.
No, I find your difference.
X to the,
So that
Is that
negative 3 comes in front, subtract 1 from there, there you go.
Hey.
Hold on.
Differentiate this.
Negative 1 to negative.
Good,
I saw your face and then I was then I laughed.
good.
I was
Can I
just-
have rewrote it again before
This one's gonna be
I slide it?
Should I have?
100%.
That's okay. That's why it looks so confusing now I'm
Yes,
looking at it.
2x.
Yes.
Good, great, okay. now
Because
we gotta
you
plug in.
missed the simplify step, right?
Yeah.
Yep.
That is
Did
your
you do the
direct-
grid?
Okay, you can simplify that, that's fine.
Let me
Don't
guess, you
simplify it.
didn't.
My bad.
I
You did. Oh, you just
didn't
ignored
do
it?
the last step.
I
should stop
I-
Michelle, should I have some water?
Yes, ma'am.
Let me see.
Wait, it looks
Only one of you
extra
should
zero.
have to go water then.
Okay, what's negative 1 minus 1?
You should have
Zero?
this.
I mean,
Yes, so x and negative 2. X to the 0, you're correct, it does just go away. But this wasn't like that.
X squared, so it's 2x, right? There's just 2x. So I think that's gonna mess her up.
This bag plays free floating around. Come on, why don't you have those five? Jeez.
Did you get negative 3 over x before? Like that?
I don't know, maybe you should buy your bag of spine and take the chiropractor.
no, I'm actually.
That's a good idea. How much does that cost?
Okay, so negative 3, I'm just like, what's on top, what's on bottom? Negative 3, I put it on top. This is going to be on bottom. So that's, I'm going to make it positive when I put it on bottom.
Oh wow, Mr. Clark, I'm like, wait.
Differentiate x squared, right?
Oh, yeah, I did that.
Make that close, yeah.
So it's just.
Yay!
Good job. So now plug in
I
negative
have a
1.
question, Michelle.
Yes.
Would this cause it to be positive if there's a negative on the outside?
No.
Okay. Would it still be minus?
Correct.
Over what?
Negative 1.
Oh, it's here, okay.
No,
Negative.
I didn't want to do this.
Because that's illegal. You don't have a common denominator. Why would you add these if you don't have a common denominator?
And then you get
You
negative
could,
4.
you would never, you wouldn't even think so. You're just gonna take negative 1 and plug it in, then you have all the terms.
Oh.
You have
Right?
negative
Not a common
2.
denominator? Okay.
Add those.
That's what I was legit. Okay.
Maybe you're right.
Negative 3
I'm slacking.
plus 1 minus 2. You know what that?
That becomes
It's negative 4.
because the negative 1 times.
So wait, I just want to talk about this
She
problem
just told me doesn't.
for a second. This problem is not hard because of any single individual step. It's hard because you have to like use a lot of different things from a lot of different places and not make a single mistake along the way. You know what I mean? Like imagine how easy it would be to just be like, oh, like I'm plugging in a negative, like to put a minus there or something. Or like it's just, do you see how like you have to be precise in everything you do to get this problem right? Yes. Also, I would say organized. Organization truly will help you. Okay? Yeah. Okay. So you have a bunch of cons that are like all a lot of cons that are like this. Alrighty, trig. Okay, so let's look at trig. So I did a spoiler alert today. But what the derivative of sine is cosine? This is crazy. Okay. So this is a graph of my original function, and this is a graph of my derivative. So just to emphasize, I'll use right here. This is a graph of y, and this is dy dx. Okay, so we have not done derivatives graphically at all. Like we've never graphed a derivative, and like gone from the function to the derivative graphically, except for I guess absolute value. But so like check it out. As I move this slider, let me move it to a good spot. Okay, I'll move it like there. So when y has a horizontal tangent line, that means the y value at the same x spot. So see how I'm at the same x. Do you see how I'm at the same x value? So if you have the slope here is the y value here. So the slope here is the y value here.
Oh, it's literally right there.
Yeah, you have this.
Oh, I didn't realize.
Yeah.
I didn't look at the
Yeah, just turn the page.
It was online, so I was like, oh.
Yeah. So the slope here, it's called screenshot, is the y value here. So like, I think this is pretty cool that so let's look at just all the horizontal tangent lines. So here, 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 here. So I assert that at all those x values, this guy is going to have x-intercepts, like zeros. So boing, let's see. See how those correspond? Those correspond. That like pi over 2. Pi over 2. Okay. Now let's just keep going. So see how on the left my slope is positive, and I'm getting steeper and steeper and positive and increasing. Check out my y value. Look on the right. See I'm positive and increasing y value?
Yeah.
Okay. Right here, do you see how at the origin sine is the steepest at the origin? The slope is the slope of sine is the highest at the origin. The y value of cosine is the highest at the origin. And then here, between 0 and pi over 2, sine is still positive. Like the slope's still positive, I mean. Slope of sine is still positive. But it's getting flatter and flatter. So over here, the y value is positive, but it is decreasing. Now look at this. On the left, my slope is negative. It's just like a little bit negative. It's close to 0, but negative. Check out over here. Close to 0, but negative. The y value. So the slope over here is the y value over there. Whoa. Okay. So see how the slope is still negative? And right when I pass through 0, so right when I get a horizontal tangent line, my slope is going to change. See how here my slope is negative, changing to positive? Here my y value is negative, changing to positive. Say that again. Slope negative, changing to positive. Slope. Y value negative, changing to y value positive. Okay, so that's not proof or anything, but we are now convinced that the derivative of sine is cosine, and then we will not explore why the derivative of cosine is negative sine, but that is true. These are memorize. There's very little you have to memorize. This is a memorize. The derivative of sine is cosine. Hasn't in this class it already come up like what's cosine of pi, right? Like it comes like stuff like that comes up a bunch. And didn't we say memorize that last year? So when we say memorize, like it's I promise you it will come up over and over and over again. Okay? So this is your warning. Yes. Alrighty, so let's do some trig derivatives. What? First example is an actual APQ. No, it's not. Okay. It's not. Okay, the derivative of 2 sine. So just like before, the coefficient just sort of like stayed in front. And then you multiplied it by an exponent, but it just stayed in front. The derivative of 2 sine. What's the derivative of sine? It is, everybody? Cosine. The derivative of 2 sine is 2 cosine. Sweet. And we're going to do an f prime equals. We're going to label, right, what's going on. Okay, next guy. Sine over 2. Woohoo! Oh, I wrote it like that. I don't know why. Cosine over 2. Cosine over 2. Ooh, okay. Do that one on your own. So you have to, you know how to take the derivative of x, and you know how to take the derivative of cosine.
It's like, oh, it looks like okay. I was like, that's a lot of functions. Good for you. And then look at this. Like, this is part of this. She like highlighted which thing.
Oh my god.
Highlighted like which part of whatever.
That's so much work. Gosh, you just call something project.
It's like, oh, this is whatever, but like,
Wow.
Brilliant.
Brilliant. That is.
No, it's,
I don't know.
All right, the derivative of x is, everybody 3, 2, 1?
X minus 1.
No, what's the derivative of x? Did you forget to derive x?
Oh.
You just rewrote it? The derivative of x is 1. Thank you,
I
Victoria.
derived the x died.
Job,
Silver did
Victoria.
it.
1.
Everyone else had a trash pickup teacher.
Yeah.
Oh wow.
So clearly I wasn't in class.
Yeah, right. Okay. We good on that
That's
though?
what I got.
C.
Thanks, Michelle.
Yeah, no, thank you. Alrighty, now we have a real life problem. Oh my goodness. So f of x is sine. So if you're finding the derivative at something, first you're going to find f prime of x, and then find f prime of pi over 3. If you don't remember what if you can't do that in your head, you have a reference sheet. It's some fun color, I believe orange. It's definitely orange, unless it's pink. Or the green one?
No.
Blue. Blue. All right. Is blue?
Thank you.
Like I said. Okay. But I know you have it memorized anyway.
What's this? I don't know.
That's the derivative.
Look at all that climate change.
No, that's so pretty.
And then just
See that
play.
Swedish actress or whatever she did?
Like Greta.
Did you see what Trump tweeted?
No, he's like, he was probably such an amateur.
Yeah, she said, this little girl is so excited for the future of our world or something like that. Obviously being sarcastic.
Oh yeah.
But like,
Okay, so a half. So pi over
The
pi over 3. Yeah. Should we go over how to do pi over 3? How is 60 degrees? It's a half. Great. So what did you learn today? It can be anything from how you know something's graphic, right? It can be anything from I learned about exponent rules, or I learned some calculus about, or I can learn I'm better at subtracting 1 from things now, right? Or no, it can actually be like I know the power rule and how to take derivative of sine and cosine. Okay, so what do you explain to your neighbor? What do you learned?